Hello everyone, my name is Pravesh and welcome back to my channel. If you're diving into Terraform and cloud automation, you probably heard about the Terraform.tf state file. But where to store that file can make or break your workflow, especially if you're working in team environment or production. So in this video, we'll break down what the state file actually is, or why storing it locally can be risky, and how to set up a remote backend using AWS S3 and DynamoDB. So for demonstration purpose, I have a basic main.tf file. So it basically creates an EC2 instance with 𝗵𝗵𝗲𝗏 as the instance type and Amazon Linux 𝗬𝗵𝗲𝗃 image. So you need to have 𝗧𝗵𝗄𝐴 CLI installed and configured with an IAM user that have appropriate permission and Terraform CLI installed. So I already have that, and let me show you when we run Terraform init and apply command. We have a Terraform.tf state file created. So let me do that first. So we have our Terraform.tf state file created here. So this file acts as the brain of your infrastructure as code setup. It stores the mapping between your Terraform config and the real world infrastructure in your cloud support. So whenever you run Terraform plan, it compares the desired state in your code with the actual state in the file to decide what needs to change. So you might be wondering, what is the problem with local state? So the local state can become a bottleneck. If you're working alone, it is fine, but in a team, two people applying changes using different state file can override or undo each other's changes. Worse, the state file contains sensitive data like API keys, token, and like password. So keeping it locally is a security risk. So let me show you how you can configure a remote backend using AWS S3 and DynamoDB. So I have this basic Terraform project. So I have also posted the code about it on the GitHub repo, and I'll link down it in the description box. Let me show you that. So this is the Terra project direct repository, and it has the code posted here. So you can simply clone it, and so let's get inside the directory. So here we first have the config.sh file. We firstly need to create the bucket and the DynamoDB table. So instead of running manual commands, I have written down a bash script so that we automate everything. So let us just see the content of it first. So firstly, we are using the shebang, which is the prerequisite for every shell script. Then we are setting -e as the flag, because if any command got any failure, so it just exit rather than running the next command. And then we are configuring our environment variable, the region as default region. We have given a bucket name. You can change it according to your requirement, and the DynamoDB table name and the state key name. So firstly, using S3 API, we are creating a bucket, and we are specifying the bucket name and the AWS region. Then we are enabling bucket versioning to maintain the version of the state file so that we can keep track of what changes are made in the file. So after that, we are creating a DynamoDB table. So we are providing the name, attribute definition, key schema, region, and throughput speed. We can also enable server-side encryption in S3, but I think it would overdo the thing, so I just avoid it. So let us just run this file. So firstly, let's make it executable. Config.sh, and then let's run it. So this will create the bucket and create the DynamoDB table. So both the table and the bucket are created with versioning alone. So now let's run Terraform init. So before that, let me show you the backend.tf file, where we have specified that our backend is configured with this bucket name. This is the bucket name which we provided earlier. The key, as it is same in the config.sh file. The region is default, and we have provided the DynamoDB table, and at last we ensure that it is encrypted. So when we run Terraform init this time, so instead of provisioning everything locally, it will store the Terraform state file in the S3 bucket. Okay, so now let's see what other things we have in this file. So we are basically creating a AWS EC2 instance, and it has a security group. So this is the security group, and it is allowing port 80 and as the inbound traffic, and allowing everything on the outbound rules. Okay, and it is displaying the public IP of the instance. So, and we are also specifying user data here. So let's go to the script also. So this is basically a shell script that creates an index.html page with my portfolio content in it. So you can see that it is just 𝗵𝗵𝗻𝗂𝗧, and these are the links to my social. So let's just run Terraform plan, and it will showcase you what are the things that will be created. So here you can see that we have 4 things to be created. So 2 of these are the rules which specify the outbound and the inbound traffic. Next, we are creating a security group, and last we are creating the EC2 instance. We have specified the ID as I have hard coded the ID. I think, let me check. Yeah, so I have hard coded the AMI ID from my region. So you need to definitely change it according to your region. Okay, so this is the configuration. Let's apply it. Here, Terraform apply. So this will output me the public IP of the instance, and within like 2 minutes I can see my portfolio index.html page on the public IP of the instance. So let's give it 2 minutes. So you can see that our instance is created. We have the public IP. We'll give it 30 more seconds so that Nginx is installed and all the index.html file is created. So while it does that, let me show you our AWS console, and let's see what are the things that were created in the bucket and the DynamoDB table. So let me just zoom in so that you can see things clearly. So we have this bucket created, and we have Terraform, and here is our Terraform.state file. So it also have versions enabled so that we can maintain the current version, and you can download this file to see the content of it. It basically contains the heart of your infrastructure as code. And let's go to DynamoDB, because we need to see the state logging thing also. So here we have our table, Terraform state log, and in this we have our string, and it has the digest hash value so that it remains locked here. So let's copy this IP and see if we have our page up here. And voila. So here you can see that we have the index.html page. So it basically contains link to my blogs and stuff. So to avoid any AWS charges, it's important to clean up the resources. So let's see. Let's just run Terraform destroy to delete all the resources. So all of our 4 resources are destroyed successfully, but we do have our S3 bucket and DynamoDB table still created. So to delete that, I have created a delete.sh file. So it simply it first emptied the bucket, and then it delete all the project, and if there are any object left, it will delete that, and after that it will delete the bucket, and at last it will use DynamoDB command to delete the table also. So let's just make it executable. And run it. So that's a wrap on Terraform state management. We explored what the state file does, why it matters, and how to securely manage it using AWS S3 and DynamoDB. If you found this helpful, give it a thumbs up and subscribe for more DevOps and cloud content. You can check out the blog post on my blog for all the code and resources. Link is in the description. So thanks again for watching. I'll see you in the next one. Ciao.